All right, so if we are dividing 8m cubed minus 14m squared plus 1 by 4m squared minus 2m plus 1, we cannot use synthetic division for this, because if we set 4m squared minus 2m plus 1 equal to 0, I don't think that we're going to be able to solve for m there. Okay, it's not factorable. Yeah, that's not factorable. So we cannot solve for m. So we have to use long division to be able to divide these two polynomials. All right, so 4m squared minus 2m plus 1 goes on the outside. Now, the same rules with synthetic division that we said about it has to be in standard form, it has to have all of its powers, those still apply. So our divisor is good. It's in standard form. It started with squared, so we need squared to the first and a constant, so we're good. Our dividends, 8m cubed minus 14m squared, we don't have an m, so we need a 0m in there. Now, the good news is with long division, it's not as integral that you have the placeholders in there, because hopefully you're paying attention and you recognize, oh, well, I cannot add 8m cubed and 7m squared. Okay, I'm not allowed to put those together. So it's a lot easier to catch it if you didn't put it in there to hold the place with long division than it is with synthetic division. Okay, so just keep that in mind. All right, so let's do this. 8m cubed, you take the first term divided by the first term. So 8m cubed divided by 4m squared is 2m. Line it up, put it over the term that had the m. Why do I do that? Because it helps me know where I'm at in the process. All right, now we multiply that 2m by that entire dividend over there. So 2m times 4m squared is 8m cubed. 2m times negative 2m is negative 4m squared. 2m times 1 is 2m. Change all your signs just of that second line. You never change what was above it, but the numbers that you just came up with, change all those signs and we add. So 8m cubed plus negative 8m cubed cancels. That's what's supposed to happen. Negative 14m squared plus 4m squared is negative 10m squared. 0 plus a negative 2 is a negative 2 plus 1. All right, repeat the process. First term divided by first term. So negative 10m squared over 4m squared. So the m squares cancel. Negative 10 is not evenly divisible by 4, so we're just going to reduce that to negative 5 over 2. Sometimes it does not divide evenly, so you might have a fraction in there somewhere. Okay, so we're going to multiply negative 5 halves by that whole 4m squared minus 2m plus 1. So negative 5 halves times 4. Remember what we did yesterday. 4 divided by 2 is 2. 2 times 5 is negative 10. That's what we're supposed to get. Negative 5 halves times negative 2 is positive 5m. And negative 5 halves times 1 is negative 5 halves. Change those signs. Add. First one cancels. Negative 2m plus negative 5m is negative 7m. 1 plus 5 halves would be 7 halves. Yes, ma'am. Where did the fraction come from? So I divide the negative 10m squared here by the 4m squared. Negative 10 is not evenly divisible by 4. So I just had to reduce that fraction there to negative 5 halves. Yes, ma'am. Yes, it did make it positive, but then I changed the signs in there. All right, so that's my remainder. The majority of the time, your remainder will just be a constant, but whenever this is 1 degree, or whenever this is less degree than the dividend, you're finished. Okay, you're also finished because we had a constant up here. Okay, you're done with the division. That entire expression right there is your remainder. So you put your remainder over the divisor, and that's the answer. This is what you get when you divide those two polynomials. This one looked a little weird because I kind of just modified the problem and didn't try and make everything turn out nice and neat and pretty. Usually they're a little bit better, and that's really nice. Okay. Any other questions? Anything else need to be clarified? We're going to do a couple more. Yes, ma'am. This, I multiplied this times the whole dividend right there. So that produces that whole line. Okay, any other questions? Let's do a couple more and make sure we're clear. Okay, 4m squared plus 28m plus 37 divided by 2m squared plus 5. Our divisor is missing the linear term, so I need to put a plus 0m in there. My dividend is not missing anything. So first term divided by first term. So 4m squared divided by 2m squared is 2. That's a constant. So line it up over your constant, 37. Multiply the 2 by the whole divisor. So 2 times 2m squared is 4m squared. 2 times 0m is 0m. 2 times 5 is 10. Change your signs. I know 0 doesn't have a negative. Just roll with it. So 4m squared plus negative 4m squared cancels. 28m plus 0m is 28m. 37 plus negative 10 is 27. That's our remainder. Because we only had that one term up there in our quotient. This degree is less than the degree of the divisor, so we can't go any further with that. So that is the remainder, 28m plus 27 over 2m squared plus 5. You don't need to put the 0m in that part right there. Okay, let's do one more. We have 18k minus 4 plus 24k squared divided by 6k plus 6. So we have 6k plus 6 right here. Our dividend is not in standard form. Okay, that k squared needs to come first. 24k squared plus 18k minus 4. So 24k squared divided by 6k is 4k. Multiply the 4k times the 6k plus 6. So that's 24k squared plus 24k. Change the signs and add. First term cancels. 18k plus negative 24k is negative 6k. Bring down the negative 4. First term divided by first term. So negative 6k divided by 6k. Negative 1. Multiply the negative 1 times the 6k plus 6. So negative 6k minus 6. Change your signs and add. First term cancels. -4 plus 6 is +2. That is our remainder. We put that over our divisor. Now this doesn't happen a lot, but we can reduce this because all those terms are divisible by 2, or we can look at it as we can factor out a 2 in the denominator. So on an answer key or as a multiple choice answer, you would see, let me write it right here. I know that 6 is the GCF, but I'm just going to factor out a 2 so that I can look at it as canceling right there. This is probably how you will see the answer. So you got a remainder of 2, but that remainder simplified with the divisor, so we go ahead and simplify that. Okay, so you have to be able to factor that out. Okay, you have to be able to factor that out. You can't just cancel. Let's look back at one of our other. Okay, right here, you can't just simplify the 28 over 2. You would have to be able to pull out a 2 from the entire bottom, a 2 from the entire top in order to be able to cancel those. Okay, so